how are you? I hope you are fine. Today we will solve a new problem number 21, which is merging two sorted lists. It's of easy level. It's really easy once we understand it. So we are given two lists, node list, okay, and it's sorted as you see 1, 2, 4, or here is 1, 3, 4. And it's required from us the output to be a new list after merging these two lists in sorted order also. So we'll bring this one here, this one here. Which one of these to bring does not matter because they are equal value. And then we have 2, and then 3, and then 4, and then another 4, and that's it. Okay, we have some edge cases we need to consider and how we approach this problem. First, what I will do, I will create a dummy node. This is dummy node, okay, and I will give it any value, doesn't matter. And then I will also make a pointer called previous, because every time we need to connect the previous with the next one, and like this will be previous, and we connect it to the next one, and then we update pointer previous to be this one, and we find which is the smallest, and we connect it to the smallest, and we update previous, and so on. But here it will be dummy node first. So when we return, we will return the dummy node. We will not return the dummy node. We will return the dummy node dot next. So this will be the next after dummy node. After dummy node, this will be next, and in this case, we will return this list. Okay. So this is solution for these two list node. I will do a while loop, while list 1 and list 2. So while we are still inbound of list 1 or inbound of list 2 and inbound of list 2, we do our operation like updating the previous and pointing to the next node and so on. But what if we have, for example, here we have more nodes like this. So this could be 7, this could be 6, this could be 7. What if you have something like this? And we are here, we reach to the outside or to the end of this list 2. So this condition is no longer valid because L2 is null while L1 is still active. So when after this while loop, we do to check if L1 still exists. We simply point the previous dot next. We point it to this. So we point from here to here. We point it this way. There's no need to go through every node here one by one. We simply, because it's only this one left and we know it's already sorted, so we just point from the last node of the result to this point. Same case happen if it is L2. If L2 is still inbound, like we have some nodes here, we point from here to here. We point it, we just point it. And to exit this loop, we will be outbound of either L1 or L2, because we are updating one, we are picking one node at a time. So first we either hit the end of this list or the end of this list. We cannot hit the end of two lists at the same time because we are taking one node either from here or from here, not both of them at the same time. So I hope this explanation is clear. Let's go to the Jupyter Lab and we start coding. So here first I will define a dummy node, and it will just be a list node of any value, doesn't matter. And first I will point previous to the dummy node as start. So we do our while list 1 and list 2 are still inbound. If list 1 dot val is smaller than list 2 dot val, so the previous dot next will point to the list 1 node, and list 1 We'll move it to the next node, will be list1 dot next. Okay, else if it is list2 less than list1, okay, then previous will point it to list2, and list2 we update it to be list2 dot next. It's that simple. Of course, in all cases we need to update the previous to be the next previous because we added a new node, and we finished here. What we left, what if we have still nodes left in list 1 or nodes left in list 2, and it can be either one of them, not both of them together. So if list 1 still exists, we point the previous dot next to the remaining of list 1. Else, that means list 2 still exists, we point previous dot next to the remaining of list 2, and we return dummy dot next. That's all. Let me copy it, test it here. It looks working normally. So let me take this code and copy it and go to the Leetcode website and test it there. So I pasted the code here and let's submit. Hopefully it will run smoothly. Yeah, and 100 best, 100% best. Very good time complexity. Let me see, the space complexity is good too. Okay, we solved this problem successfully. Thank you very much for watching. Please leave a comment and I'll see you in the next problem.